Hey Jordan, just doing a quick video going over recurrence relations and what they are. Okay, so a recurrence relation, what it's used for, it's just pretty much a mathematical sentence or phrase that tells us what the value of something will be after each term. So whether it be after each year, after each month, all right, and so on. Okay, so what I'm going to do is I'm going to start with an example. The first example is going to be an arithmetic one. Okay, then I'll do a geometric one. So I'm just going to make this up. I'm going to say someone bought a scooter. Okay, and they bought it at, I don't know, $1,200. It's a really expensive scooter. Okay, and each year the scooter is going to be going down in value by $55. Okay, so rather than work out the value like we know it's originally $1,200 minus 55 after 1 year, it'll be 11.45 and so on. What we can do is we can actually write a rule or a recurrence relation explaining what the value of the scooter will be after so many years. Okay, and these recurrence relations, they're always written the same. Okay, so it's always following the same rule. And once you get used to them, yeah, you'll be smashing it. Okay, so it always starts with V0, okay, or T0, or, if it's the scooter, maybe it's S0, I'll use S0. And that's just the original value of the scooter. Okay, so when it was first bought, it was $1,200. Okay, then we do a comma. And then this next part, what it is Sn plus 1. So it means the value of the scooter, or the next value of the scooter, is the value before, so Sn, because this is one more than the one before. All right, and each time we're minusing 55. Okay. So for example, I'll use this recurrence relation. If we're trying to find the value of the scooter after 1 year, okay, it's going to be, we've got our $1,200 to find the next value, so S1. It's going to be the one after the one before, so it's going to be S0 minus 55. Okay, and we know that that value of S0 was $1,200 minus 55, okay, and as we worked it out before, it was 11.45. Okay, and then we can continue this. So S2 is going to be, and I'm just going to do from the right-hand part, I'm not going to worry about this. S2 is going to be the value of S1, so the term before, minus 55. Okay, and we worked out the value of S1 as this 11.45. So S2 is going to equal 11.45 minus 55. Okay, which will be $1,090. Okay, so then, and we can just keep going. We can go to S3 and we're using, the value of S2 and we're minusing 55 and so on. But essentially, Jordan, all you're starting off with, like if it asks for the recurrence relation, it wants you to put what the original value is or the starting value of whatever it might be. It doesn't have to be your value, okay? It could be the number of trees in a forest, okay? And it's because of deforestation. They're losing trees in the forest. Okay, I've just started with money. Okay, so you start with the original amount, and then to find the next value, you use the term before, and then, whether you're adding, subtracting, or whatever here goes here. Okay. Now I want to do a geometric example. Okay, and I'm going to do something, what example? I might do I'll do something that's going up in value. So just something goes up in value is a house. Okay, so a house might be $200,000. Okay, and each year it's gaining interest, so it's going up in value. Okay, and the interest rate might be, or the R value, sorry, the common ratio might be 1.03. Okay, so what we're going to do is we might get this question. We've got a house at $200,000. Each year, the common ratio is 1.03. Find or write the recurrence relation. Okay, so it's actually the exact same as arithmetic, except at the end, we're not going to be minusing and adding. We're going to be timesing. Okay, so I'll start it off, because it was a house, it might be H0. It'll usually tell you which one it wants you to do. So H0 equals the original amount. Okay, and that's comma to find the next value of the house. What we do is we use the value before, or HN, sorry. And then we're going to multiply that value before by 1.03. Cool. All right, so for example, if we're trying to find H1, what we're going to do is, that's going to be the value before, so it's H0, which is this 200,000. So I'll just put 200,000 times the 1.03. Okay, and if we work that out, I'm just going to make up a value. It might be 206,000. Okay, and then to find H2, again, if it's H2 here, we're using the value before, so this value times the 1.03. Okay, and goes on. So what this recurrence relation does, Jordan, it just gives us like a statement telling us how we find the next value of, I keep saying value, but the next number in the sequence. Okay, so with arithmetic and geometric, they're all the same, except arithmetic, you're going to be adding or subtracting at the end, and geometric, you're going to be multiplying. Cool, so hopefully that explains it a bit better.